Hello, and welcome to the Sleepy Astronomer. Tonight, as we drift among the stars, I want to ask you, where in the world are you watching from? Whether you're in a quiet corner of the countryside, or wrapped in a blanket on a city rooftop, I'm so glad you're here. Tonight's journey is a slow, peaceful meditation on one simple, beautiful question. Why will we never touch a star? Let's lie back, look up, and begin our stargazing adventure. If you've ever looked up at the night sky and felt a sense of quiet wonder, you're not alone. For thousands of years, people all over the world, farmers, poets, sailors, and dreamers, have gazed upward, mesmerized by the gentle shimmer of stars scattered across the dark fabric of the heavens. But before we ask why we'll never touch a star, we must first ask a much simpler question. What is a star? At first glance, stars appear to us like tiny pinpricks of light, small, still, almost delicate. They twinkle, they flicker, and they seem almost fragile against the vast night. But the truth is, each one is a roaring, powerful furnace, burning with unimaginable intensity. A star is not small. A star is not silent. A star is not calm. A star is a colossal sphere of hot plasma, held together by the force of its own gravity. It's born from giant clouds of gas and dust that swirl through galaxies, waiting patiently in the silence of space until gravity stirs them into motion. As these clouds collapse inward, their centers grow hotter and denser, until one quiet moment, something extraordinary happens. Nuclear fusion begins. This is the spark of life for a star. At its heart, hydrogen atoms crash into one another with such force that they fuse together, forming helium, and in the process they release a staggering amount of energy. That energy pushes outwards, fighting against the pull of gravity, and creates a balance that allows the star to shine steadily, often for billions of years. Our own sun is one such star. It's easy to forget, because it looks so different from the stars at night. But the sun is a star, and it's not particularly special. In fact, it's quite ordinary, a middle-sized star in a quiet corner of a spiral galaxy. And yet without it, none of us would be here. Every sunrise, every breeze, every growing tree comes from the warm and constant energy of that one single star. But beyond our sun are stars far stranger. Some are giants, hundreds of times larger than our sun, glowing in deep red or blue. Others are small and faint, barely visible, whispering their light across vast distances. Some spin wildly, others pulse like slow, glowing heartbeats. There are stars that orbit each other in pairs, some that are just being born, others that are dying, collapsing into dense remnants like neutron stars, or disappearing into black holes, where even light can't escape. And what's even more humbling is that we see only a fraction. There are more stars in the universe than grains of sand on all the beaches of Earth, more than our minds can hold. And yet, every star is made from the same basic ingredients: hydrogen, helium, and the occasional trace of heavier elements. The same atoms that once floated freely through the early universe, drifting in silence, waiting for the moment they would be called into being. Stars are the engines of the cosmos. They give birth to planets. They forge the elements that make up everything we know: carbon, oxygen, iron. The calcium in your bones, the oxygen you breathe, the iron in your blood were all born in the heart of a star. To say, what is a star, is to ask, in a gentle way, what are we made of? Because we are not separate from the stars. We are made of stars. And while we may never touch one, they have already touched us. Their light travels across unimaginable distances just to meet your eyes. Their atoms rest quietly inside you, carried through time by the winds of the universe. Their births and deaths have shaped the galaxies, lit up the night skies, and woven the very structure of reality. So when you look up tonight and you see one flicker faintly above your roof, or through your window, or behind a curtain of clouds, know this: that soft sparkle is not a small thing. It's not just a twinkle. It's a silent roar of energy. A sun burning with light, waiting patiently for you to notice. And now you have. Let's drift deeper into this story and discover why, despite our wonder, we may never truly touch one. When you gaze up at the stars, you may feel as though they're watching you back, steadily, softly, as if they've always been there and always will be. But there's something deeply magical and a little haunting about what we're truly seeing. Because in a very real way, when you look at a star, you are looking into the past. Not the past of a few seconds or minutes, not even days or years, but sometimes hundreds, thousands, even millions of years ago. That soft light drifting down through the atmosphere, landing gently on your eyelids as you lie in the dark, began its journey long before you were born. Light, as fast as it is, still takes time to travel. It moves at nearly 300,000 kilometers per second. That's fast enough to circle the Earth 7 times in just 1 second. And yet, even at that unimaginable speed, the light from the stars has been travelling for ages. The nearest star beyond our Sun, Proxima Centauri, is over 4 light years away. That means the light you see tonight from Proxima began its journey 4 years ago. 4 years ago. Maybe you were in a different job. Maybe you lived in a different place. Maybe you were a different person entirely. And yet, while all those changes happened down here, that tiny beam of light from a distant sun was flying through space, heading toward you, quietly, constantly, with nowhere to land except here. Now stretch that idea further. Imagine stars that are not 4 light years away, but 40 or 400 or 4 million. Some of the stars you see on a summer night began shining before humans even walked the earth. Some started their journey when woolly mammoths roamed frozen valleys, or when oceans were still forming, or even before Earth existed at all. The further away a star is, the further back in time we are looking. The night sky, then, is not just a ceiling of stars. It is a time machine. Each tiny point of light is a ghost of the past, a message from long ago. Some of the stars we see may not even be there anymore. They could have burned out, exploded, or collapsed into black holes. But their final light is still making its way to us, like a farewell echo travelling through the empty dark. And this distance, this delay, is not a failure of the universe. It's not a glitch or a mistake. It's part of the beauty, because it means we are connected to the vast, ancient story of everything. Every time you look at the sky, you are catching a glimpse of a universe in motion, suspended between what was and what is. You're not just looking at stars, you're looking at time itself. And what a gentle thing it is to sit beneath those ancient lights, knowing they have seen ages come and go. Civilizations rise and fall, mountains grow and crumble, species appear, flourish and vanish, and still they shine, still they travel, still they arrive, quietly, invisibly, without sound or ceremony, just to meet your eyes in this one moment. You may feel small in comparison, but remember, it took the entire history of that star's light just to find you here tonight. Out of all the infinite places that light could have scattered, it ended up right here, landing gently on your skin as you breathe slowly, maybe already drifting into sleep. It's easy to think of light as something quick, something that flashes, something momentary. But starlight is patient. It waits. It moves forward through nothingness, across frozen distances and silent galaxies, without ever pausing, without ever doubting. A promise that was kept over millions of years. And so when we ask why we'll never touch a star, part of the answer lies here. Because we never really see a star as it is. We only see what it was. There is always a space between us and the truth of it. A delay. A dreamy veil of time. We chase it across the universe, and by the time we arrive, if we ever could, the star we reached would already have changed. It may have swelled into a giant, or shrunk into a cinder. It may no longer be shining. But the light, its light, still reaches us, still touches us, still reminds us that the universe is vast, ancient, and still speaking to us in its own quiet way. And so, we lie here, in silence, in softness, under a sky filled with the past. The sky does not rush, the stars do not hurry, and neither do we. Let's drift even deeper and explore the mysterious space between us and those unreachable fires above. The human mind is wonderfully curious. We build bridges, sail across oceans, and send messages through the air. We even launch tiny metal ships into space, hoping to explore the stars we've gazed at for millennia. But there's one thing that our imagination struggles to truly grasp: distance. Especially the kind of distance that exists out there, in the dark silence between the stars. Down here on Earth, distance feels manageable. You might walk to the store, drive across town, fly across a country. Even the tallest mountains, the widest deserts, and the deepest oceans, these are still earthly things. We can measure them, cross them, conquer them. But in space, distance is something else entirely. The closest star to our planet, aside from the Sun, is Proxima Centauri, a red dwarf star just over 4.2 light years away. That may not sound so far. 4 light years, just 4. But let's take a quiet moment to understand what that actually means. Light travels incredibly fast, about 300,000 kilometers per second. In just 1 second, a beam of light could circle the Earth 7.5 times. It's the fastest thing we know. And even at that speed, it still takes more than 4 years to reach us from our closest stellar neighbour. Imagine turning on a flashlight and waiting 4 years for someone on a nearby planet to see it flicker. Now imagine trying to go there yourself. If you were to fly in the fastest spacecraft we've ever built, NASA's Parker Solar Probe, you would still need over 17,000 years to reach Proxima Centauri. By the time you arrived, the language on Earth would have changed. The cities would have disappeared. The very shape of the continents might be different. And that's just the closest star. Most of the stars you see twinkling gently above you aren't 4 light years away, but tens, hundreds, even thousands of light years from Earth. Some are so distant, their light has taken longer to reach us than human civilization has existed. Others are so far that their glow began its journey before Earth even had life. And between those stars is something even more difficult to understand. Space itself. Not just empty space like we think of between furniture or between clouds, but a vast, silent ocean of pure nothingness. No air to breathe, no sound to hear, no gravity to hold you close, just the frozen vacuum stretching in every direction, with no signs, no road maps, and no shortcuts. The farther you go, the more you feel this silence, this emptiness, this growing awareness that space is not built for us. It does not invite us in. It does not push us away. It simply is cold, endless, patient, and yet we still dream of crossing it. We look at the stars and imagine visiting them as if they were distant islands waiting for ships to arrive. But even the fastest dreams are slowed by the weight of reality, the technology we would need, the time it would take, the unimaginable fuel, patience, and resilience. Space is not measured in kilometers or miles. It's measured in light, in time, in a kind of loneliness that only the universe truly understands. And there's another challenge, one that lies not in the distance itself, but in the expanding nature of the universe. Because space isn't just big, it's growing. The stars are not standing still. Galaxies are drifting away from us, carried by the steady swelling of the cosmos. With every second that passes, the gap between us and the stars gets just a little bit wider. Slowly, silently, they're receding, like ships fading into a foggy horizon, never to return. The stars we see now are not only far away, they are getting farther. And someday, billions of years from now, those stars will vanish from our skies entirely. Their light, stretched and thinned by the expansion of space, will no longer reach us. The night sky will go dark, not because the stars are gone, but because their distance will have grown too vast to bridge. In that far-off future, someone might look up at the sky and see only blackness, never knowing that the universe once sparkled with endless fire. But here and now, we are lucky. We still see them, still feel them above us, still imagine touching them, even if we never will. Because that's the quiet truth behind all of this. The stars are not just far away, they are impossibly, beautifully out of reach. Not because the universe is cruel, but because it is grand. Because it is vast beyond comprehension. Because some things are meant not to be held, but simply to be wondered at. And so we lie beneath them, still, small, safe. We wrap ourselves in warm blankets. We close our eyes. and we let the stars remain where they are, distant, glowing memories stitched into the fabric of the sky. Out of reach, but never out of sight. There's something so peaceful about the way stars appear in the night sky. Their light is soft. Their glow is steady. They seem cool, distant, and quiet, as if they might be cold to the touch, like little frost-covered lanterns suspended in the dark. But that's an illusion, a beautiful one, because stars are not cold at all. They are not gentle. They are not quiet. A star is a furnace beyond anything we can truly comprehend, a raging, relentless fireball that never stops burning. And if we were ever to try to touch one, even from a great distance, the result would be instant, utter destruction. To touch a star would be to step into fire. Not fire as we know it here on Earth, but fire without boundary. Fire without air. Fire so hot that even atoms themselves break apart. Let's begin with the Sun, the only star close enough to truly study. Its surface temperature is around 500 degrees Celsius. That's hot enough to vaporize iron, melt rock, and destroy anything we've ever built. But the Sun's surface is actually the coolest part of it. Go a little deeper, and things become almost impossible to describe. At the core of the Sun, where the real magic of fusion happens, the temperature climbs to over 15 million degrees Celsius. That's not a typo. 15 million. It's there in that unimaginable heat where hydrogen atoms are forced together with so much pressure that they fuse into helium, releasing energy in the process. This is the engine of the star, the beating heart that keeps it alive. And the Sun isn't even a particularly hot star. There are stars in the universe that burn far, far hotter. Blue giants, for example, can reach surface temperatures of 30,000 degrees or more. That means their cores are even more extreme, so hot that they make our Sun seem tame in comparison. Now imagine trying to approach something like that. Even with a shield, even with a spacecraft, even with the strongest materials we can imagine, the heat radiating from a star would vaporize anything long before it got close. Not melt, vaporize. The radiation would be equally unforgiving. Gamma rays, ultraviolet waves, X-rays, all flooding outward from the star in every direction, stripping away electrons, frying circuits, and tearing through matter like invisible blades. The light from a star isn't just warm, it's violent. It's energy in its purest form. And even light, which takes just 8 minutes to reach Earth from the Sun, carries enough power to burn skin, blind eyes, and slowly change the surface of our planet. That's just from this far away. Get closer, and things become far more extreme. There's no solid ground on a star, no surface to step on. It's not like a planet where you can land and explore. A star is made entirely of plasma, superheated gas that's been torn apart into a sea of ions and electrons. If you tried to land, you'd fall straight through the outer layers, down into hotter and hotter regions, until you were completely disintegrated. Even robotic probes wouldn't survive. No metal, no matter how advanced, could handle those temperatures. The strongest alloys would melt into vapour, the electronics would be fried, and the magnetic fields would twist and crush whatever was left. You wouldn't even get close enough to fail. You would fail long before arriving. And yet, from here, From our little blue planet, stars look like something we could touch. They twinkle like diamonds. They shimmer like distant candles. They feel almost reachable. Like if you stretch just a little farther, you might graze one with your fingertips. But they are not fragile. They are not soft. They are not gentle. They are wild, roaring explosions of energy, barely contained by gravity. And they have been burning steadily for billions of years, long before we were born, long before there was an Earth to watch them. And they will continue to burn long after we are gone. In their presence, we are small, and that's okay. In fact, it's comforting, because it reminds us that the universe does not depend on us to keep going. The stars will rise whether or not we look up. They will burn whether or not we understand them. They exist on a scale so vast, so hot, so far beyond us, that all we can do is admire them from a safe distance. And maybe that's enough. Maybe that's better. Because if we could touch a star, if we could hold it in our hand, or stand beside it, or feel its warmth directly, it wouldn't be a star anymore. It would have to be something smaller, tamer, something less than what it truly is. To be a star is to be untouchable. To burn with the kind of fire that holds planets in orbit, to shine across the galaxy, to survive the collapse of time itself. And so, we watch from afar, grateful for the space between us, grateful for the light that travels across that distance, landing softly on our skin, grateful that something so fierce, so hot, so deadly can look so calm. Because there is something deeply beautiful about knowing we are surrounded by fires we'll never touch. That the night sky is filled with silent, burning suns that give us warmth, meaning, and wonder from just far enough away to dream about. And tonight, as you close your eyes, let the light of those distant fires continue to flicker behind your eyelids. Let it remind you that there are things too powerful to hold, and that some of the most beautiful things in the universe are the ones we simply watch and never touch. When we imagine reaching for the stars, it's easy to picture ourselves climbing aboard some elegant spaceship, shiny, fast, unstoppable, soaring effortlessly through space, past the moon, past the planets, past the lonely comets and asteroids, until we finally glide into the glowing arms of a distant star. It's a dream rooted deep in the human spirit, the idea that with enough ambition, enough brilliance, enough time, we can go anywhere. But tonight, as we rest beneath the quiet blanket of night, let's take a gentle walk through the truth. Let's explore why, no matter how advanced our technology becomes, no rocket will ever truly carry us to the stars. Let's begin with something we already know. Space is vast. Unimaginably so. The distances between stars are not measured in kilometers or miles, but in light years, units that describe how far light travels in a single year, moving at 300,000 kilometers every second. Even the fastest spacecraft ever built by humans, NASA's Parker Solar Probe, moves at around 700,000 kilometers per hour. At that pace, reaching the closest star, Proxima Centauri, would take over 17,000 years. 17,000 years. Longer than all of recorded human history. Longer than the time since the first cave paintings. Longer than language, agriculture, cities, empires, whole civilizations would rise and fall in the time it would take to make that single journey. And that's to the nearest one. The other stars we see each night, they are vastly more distant. To travel to them, we would need to multiply that 17,000-year trip again and again and again. You could fly through space for hundreds of thousands of years, never aging, never stopping, and still never reach most of them. So we think, perhaps we need a faster ship, a better engine, one that could move at the speed of light. But even that presents a new problem. As you move closer to the speed of light, everything begins to change. Time slows down, mass increases. The energy required to move even a single gram of material rises toward infinity. According to the laws of physics, reaching the speed of light is impossible for anything with mass, like a spaceship, or a human body, or even a grain of sand. It's not a limit we can overcome. It's a boundary built into the very nature of reality. But let's imagine, just for the sake of wonder, that we somehow built a ship that could move near the speed of light. We would then have to face an entirely different challenge, space itself. The space between stars is not just vast, it is dangerous. There is no air. There is no heat. There is no friction to slow you down. But there are tiny particles, dust, radiation, rogue atoms, floating silently in the void. And if you're moving fast enough, even a single grain of dust could destroy your ship in an instant, like a bullet colliding with a soap bubble. And then there's time. If a ship took thousands of years to reach a star, who would pilot it? Who would live aboard it? No human lifespan could stretch that far. We'd need to send generations of people, born and raised in deep space, or put everyone in frozen sleep, or send machines instead, robots, probes, artificial minds. But even that isn't so simple, because communication becomes slower the farther we go. A message sent from 4 light years away would take 4 years to reach Earth. If something went wrong, we wouldn't even know until years after it happened. We would become ghosts in the galaxy, travellers so far from home that Earth would become just another star in the sky, a tiny dot behind us, fading with every passing year. And then there's the fuel. Rockets require fuel to move, and the farther and farther we want to go, the more fuel we need. But fuel has weight. The more fuel you carry, the heavier the ship becomes, and the more energy you need to move it. It becomes a loop, a frustrating, endless cycle. More fuel means more weight means more fuel. There is a point where it becomes impossible to carry enough. Even our most advanced engines, ion drives, solar sails, nuclear propulsion, only nudge us forward slowly, gently. They are miraculous inventions. But compared to the size of the cosmos, they are like feathers drifting on the wind. In the end, the stars remain still, silent, unreachable. Not because we lack the courage to go to them, but because the laws of the universe have made them distant by design. And maybe that's not a failure. Maybe that's the gift, because it means the stars remain a mystery, a reminder, a quiet presence that exists just beyond our grasp. We don't need to touch them to be connected to them. We don't need to land on their surfaces to belong to the same story. They shine for us. They send their light across space, down through our atmosphere, across fields and rivers and rooftops, until it lands softly on our skin. The light of a star travels not to be caught, but to be seen, to be felt, to be dreamed about. So we build rockets, not to touch stars but to feel closer to them, not to conquer space, but to explore our place within it. We launch telescopes into orbit. We send little golden records into the dark. We listen for whispers from distant galaxies. And we do it all because we are part of the same universe, made of the same matter, lit by the same fires, carried by the same silence. So tonight, you don't need a spaceship. You don't need a rocket or a suit or a map. You just need to lie back and look up. The stars are far beyond our reach, but they are never beyond our wonder. And that is enough. When we look at the night sky, it feels so still, so peaceful. The stars appear frozen in place, like tiny pearls stitched onto a great black curtain, eternal, unmoving, familiar. But this too is an illusion, a beautiful, comforting illusion. Because the truth is, the stars are not still, not even a little. They are moving, drifting, dancing, spiralling at astonishing speeds through the great, quiet ocean of space. Every single one of them. And yet, from where we are, resting beneath the sky, it's nearly impossible to tell. We see Orion in winter. We see the Big Dipper in spring. We learn the constellations, name them, trace their shapes with our fingers in the air. And they feel eternal, like old friends who return again and again, always in the same place. But in reality, the stars are slowly, steadily shifting, not just across the sky each night, but over years, centuries, eons. They are in motion, not metaphorically, but truly. Literally. Some are rushing toward us. Some are drifting away. Others swirl within their galaxies in slow, graceful orbits. They are pulled and pushed by gravity, affected by ancient collisions, guided by the gentle tug of dark matter and cosmic flows. The star Vega, for example, bright and bluish in the summer sky, is moving toward Earth at about 13 kilometers per second. It will become our North Star in about 12,000 years, taking the place of Polaris. In time, the constellations will twist and warp. Shapes we once knew will fade, and new patterns will take their place. If someone were to lie under the stars 100,000 years from now, their sky would look unfamiliar, foreign. The same stars perhaps, but arranged differently, like pieces of a puzzle that have been slowly shuffled. So why don't we notice? Because space moves slowly across a human life. The stars are far away, and even great speeds look like stillness when viewed across that distance. It's like watching a mountain from a window. You can drive for hours, and it hardly seems to move. That's what the stars are like. They're in motion, but their motion hides behind time. And yet, if we could speed things up, if we could watch the night sky on fast forward, we'd see something incredible. We'd see the stars swirl around the galactic core, each one tracing its own silent arc. We'd see entire clusters drifting like flocks of birds. We'd see the Milky Way itself turning, a spiral of light and dust spinning slowly in the darkness. It would be beautiful and strange and maybe a little humbling, because it reminds us that the universe is alive, not in the way living things are, but in the way that rivers flow and clouds form and tides rise and fall. It moves with purpose. with rhythm, with quiet persistence. Even our own sun is not standing still. Right now, the entire solar system is travelling through space at roughly 828,000 kilometres per hour. That's fast enough to cross the entire United States in less than a second. And yet, because everything around us is moving at the same pace, our planet, our moon, the air, the stars in the distance, we don't feel it. It's like sitting on a smooth train ride, gliding across the country. You don't feel the motion, but outside, the world rushes by. The stars, too, are passengers on a cosmic journey. Some stars are part of binary systems, two stars locked in a slow, endless orbit around one another. Some are part of star clusters, drifting together through space like glowing rafts on a dark ocean. Others are wanderers, flung through the galaxy by ancient explosions, travelling alone and unseen. And then there are the galaxies themselves, because even the stars are part of something bigger. Each galaxy is a spinning wheel of stars, billions upon billions of them, turning slowly across the universe. And those galaxies are moving too, clustering together, colliding, merging, spinning, expanding outward with the growth of the cosmos itself. The universe is a dance, not a chaotic one, but a slow, graceful waltz. One that began nearly 14 billion years ago and will continue long after we are gone. And here we are, lying beneath it all, still, small, dreaming. It's easy to feel separate from all of this motion, to feel as though the stars are up there and we are down here, quiet observers watching the show. But that's not quite true, because we're part of it. Our sun is a star. Our planet is its companion. We orbit, we spin, we move. We are woven into the same motion. We are not standing still. We are riding this cosmic carousel, holding on gently, barely noticing their turn. And maybe that's why the stars are so soothing. Because even though everything is moving quietly, constantly, we don't need to keep up. We don't need to understand every orbit or measure every speed. We don't need to see the dance to be part of it. We are part of it simply by being here, by breathing, by dreaming, by looking up. So tonight, as you lie beneath the stars, know that nothing around you is truly still. And that's a beautiful thing. The stillness you feel isn't the absence of motion. It's the harmony of everything moving together, slowly, quietly, perfectly. And while we may never touch a star, we are already riding beside them, across the darkness, through the silence. Together, imagine for a moment standing under a dark sky with no clouds, no lights, and no noise, just you. And the stars, they seem fixed, eternal, always in the same patterns, always in the same places, quietly watching over the earth. You may feel as if you could draw lines between them and connect them, like a gentle dot to dot in the heavens. But here's the secret. What we see is not quite what is. Because the stars don't sit neatly across a flat canvas. The sky isn't a ceiling, and the constellations aren't real shapes in space. They're illusions, beautiful illusions created by the limits of our perspective. When you look up, you're seeing stars that appear close together, but in reality, they could be separated by hundreds or thousands of light years. Their positions in the sky are simply a trick of distance and angle. Like trees in a forest, They line up in ways that look meaningful from one point of view. But step a few paces to the side and the shapes change. Our ancestors looked at the sky and saw stories. A hunter, a lion, a scorpion, a great bear, a hero holding a snake. The constellations were born from imagination and wonder, etched into the heavens as myths. But the stars within each constellation are not bound together. They are strangers to one another. They do not know they are part of a shape in our sky. They are not clustered in space the way they appear to be. They are scattered. Some are near, some are very far. Take Orion, the hunter. His bright belt is made up of 3 stars that seem to sit side by side, yet in truth they are at very different distances from Earth. If you could float above the galaxy and look back from another angle, you'd see that Orion disappears. The shape is gone. The stars scatter into a new pattern, one we cannot even imagine. The sky is not a map, it's a window. And like all windows, it only gives one view. When we look at a star, we see only one dimension, direction. But the third dimension, depth, is invisible. The stars don't reveal how far they are. They don't glow brighter the closer they get, or dimmer the farther they move. Their brightness is affected by many things: their size, their temperature, their age, and yes, their distance too. But that alone can't guide us. 2 stars could shine equally in the sky, while one is only a few light years away and the other lies thousands of light years beyond. This illusion of nearness creates a beautiful lie that the stars are part of a single fabric, that the sky is a painting we can trace with certainty. But really, the night sky is like a great shadow play, 2-dimensional to our eyes, but 3-dimensional in truth. A stage with infinite depth, where every star is its own character, telling its own story, unaware of the constellations we've drawn between them. And yet, these illusions have meaning. They help us remember. They help us navigate. They let us tell stories, connect to our ancestors, and pass down myths from generation to generation. A child in ancient Egypt, a sailor on a Polynesian canoe, a shepherd in Greece, a traveller today with a stargazing app, they all look at the same patterns. They all see the same imaginary shapes. And even though they aren't real, those shapes have become part of us. So in a way, the illusion is not a flaw. It's a gift. It reminds us that we are storytellers, that we make sense of the world by connecting the dots, even when the dots are scattered across the galaxy. But there's more, because the illusion doesn't stop with shapes. It continues with motion. Each night, the stars appear to move across the sky, rising in the east, setting in the west, just like the sun. But they're not moving, we are. The Earth is rotating, spinning gently on its axis. It makes a full turn every 24 hours, and as it turns, our view of the sky shifts. Like someone turning in a dark room filled with candles, we see new lights come into view, while others fade behind us. So when you watch a star sink toward the horizon, you're not watching it fall. You're watching yourself turn away. The illusion is subtle but profound, because it means that the sky you see is not separate from you. It moves because you move. It changes because you are part of the change. And over the course of a year, the night sky shifts again, this time because the Earth is moving around the Sun. As our position changes, new stars come into view, new constellations rise, while old ones slip below the horizon. The sky becomes a calendar, a quiet record of time, reminding us where we are in the grand cycle. Even time, it turns out, is woven into the illusion, because some of the stars we see may no longer exist. Their light began travelling toward us hundreds or thousands of years ago, and while they may have faded or exploded long ago, their final beams are still racing toward Earth, still visible in our skies. It's like hearing the echo of a voice long after the speaker is gone, a quiet ghost of light. So when you look up, you are not seeing the sky as it is. You are seeing it as it was. A layered vision, a memory. A sky stitched together from many different places, many different times. And yet, despite all these illusions, all these tricks of distance and time, what you feel when you look at the stars is real. That awe, that stillness, that gentle ache of wonder. It's not an illusion. It's the deepest truth of all. Because the stars remind us that even in a world of shadows and mysteries, there is beauty, there is order, there is light. And even though we may never touch them, they touch us, not with heat, not with weight, but with meaning. So tonight, let the stars be what they are: far, scattered, mysterious, and beautiful. Let the illusions remain, because sometimes the things that aren't quite real are the ones we hold closest to our hearts. Close your eyes for a moment and imagine it, the dream we've carried for centuries, to touch a star, to reach out through the void and place your hand against that glowing, radiant surface, to feel its warmth, to stand in its presence, to be so close to something so ancient, so bright, so powerful. But the truth is this: to touch a star, we would have to stop being what we are. We would have to let go of everything human, everything physical, everything earthly. We would have to become something else entirely. We would have to become light. Let's take a quiet walk through this idea. At the heart of every star is a force so intense it transforms matter itself. A star is a place where hydrogen atoms, the simplest, most abundant particles in the universe, are crushed together under enormous pressure and heat, fusing into helium and releasing incredible amounts of energy in the process. This energy is light. Not just the kind of light we see, but every form of it: ultraviolet, infrared, X-ray, gamma ray. It radiates outward in all directions, racing through space at 300,000 kilometers per second. And it continues to travel, unbothered by the cold, the dark, or the emptiness, until it finally touches something, or someone. Light is the only thing that truly escapes a star. Matter is bound by limitations, by weight, by resistance, by time. But light is free. It is pure energy. It has no mass. It doesn't age. It simply moves forwards eternally until it is absorbed or scattered or faded away. And so, if we ever wanted to reach a star, not with machines or ideas, but with ourselves, we would have to become like the only thing that can touch it. We would have to become light. But what does that mean? It means shedding all the things we think of as solid. Our bodies, our breath, our bones. Even our thoughts, shaped by neurons firing in a physical brain, would have to dissolve into something lighter. Something not held back by time, or temperature, or distance. It means letting go of form and becoming energy. Can you imagine that? Drifting across space, not walking, not flying, but simply being movement. Not burning, not freezing, just existing perfectly at the edge of reality. Slipping past the boundaries of the universe in silence. And only then might you arrive at a star, not as a visitor, but as something woven into its light. You wouldn't land. You wouldn't stand. You wouldn't look around. You would join. You would become part of the endless brightness that surges from its core. You would race outward with every photon. You would be a sunbeam, an echo of fusion, drifting across galaxies. And you would never stop, because once you are light, you cannot pause. You cannot rest. You're always moving forward across the vast emptiness, with no destination, no end. You would shine, but you would no longer be you. And that is the quiet paradox of our dream to touch the stars. To reach them in the most intimate way, to truly connect, we would have to give up the very thing that makes us long for them. We would have to surrender our humanity, our warmth, our longing, our sense of self. Because stars do not meet us where we are. They exist in a realm beyond touch. We can build ships. We can fly probes. We can measure and map and send our voices into the dark. But to touch a star, to truly become part of it, is not something a human can do, unless we become light. But perhaps there's another way to understand this dream. Perhaps the point is not to reach the star with our hands, but with our imagination, with our wonder. Because in a very real sense, the light of a star already has touched you. Every morning when sunlight warms your face, every time moonlight, reflected from the sun, glows on your pillow at night, every breath you take, filled with oxygen once crafted in a stellar core, every heartbeat powered by the atoms left behind by ancient stars. You are already part of them, formed from their remains, nourished by their light. So perhaps we don't need to become light to reach them. Perhaps we already are. A long, long time ago, a star exploded somewhere in the galaxy. It released its contents, carbon, iron, oxygen, into space. Those pieces drifted, joined clouds of dust and gas, and eventually helped form our sun, our planet, our bodies. The atoms in your hands, your heart, your breath, were born in the heat of a star. So you see, the stars are not far. Not really. They're inside you. You don't need to go to them. You are them. You are the result of their fire. You are the echo of their brilliance. You are the child of their death, and the carrier of their light. And in that way, the dream comes full circle. You don't need to touch a star, because in the deepest, truest sense, you already have. When we speak of stars, we often think of the distant ones, the icy points of light scattered across the black velvet sky. But there is one star that we know more intimately than any other. One that we see not as a dot, but as a golden disk. One that rises each morning, paints the sky with warmth, and then sinks again beyond the horizon, only to return the next day. Our sun. It's easy to forget that the sun is a star. That glowing presence in the sky feels so different from the others. It doesn't twinkle. It doesn't seem unreachable. It's right here, with us, woven into the rhythm of our days. We wake with it. We grow food beneath it. We gather our warmth and energy from its steady glow. It feels close, familiar. And yet, even the sun is out of reach. It sits at the centre of our solar system, 150 million kilometres away. That number may seem abstract, but try to imagine it in this way. If Earth were the size of a small marble, the sun would be a blazing ball the size of a large beach ball, sitting 15 metres away. That's the scale we live within. That's the gap between us and the nearest star. And it's not just the distance that keeps us apart. The sun is a seething, living fireball. At its surface, the temperature reaches over 5,400 degrees Celsius. But this is just the beginning. As you move inward through its layers of plasma and magnetic chaos, the heat rises unimaginably. In the core, where nuclear fusion occurs, the temperature soars to over 15 million degrees Celsius. This fusion is what powers the sun. It is the slow, steady joining of hydrogen atoms into helium, a process that releases energy in the form of light and heat. That energy then travels outward, moving through the dense interior of the star over tens of thousands, sometimes even hundreds of thousands, of years before it escapes into space. And once it does, it becomes sunlight. The warm, golden light that falls on your skin, that feeds the trees, that dances on the ocean waves, that sparkles on snow. But this light is not immediate. It began its journey long ago, buried deep inside the sun. It struggled particle by particle through layers of dense gas, bouncing and scattering and colliding for eons, before finally emerging into the vacuum of space. Once free, it takes just 8 minutes to reach Earth. So when you feel sunlight on your face, you are feeling energy that was born in a star. Energy that fought its way out across unimaginable odds to find you. And yet, if we tried to reach back, if we tried to visit this familiar star in return, we would find only danger. No spacecraft could survive the journey. We've sent probes, like the Parker Solar Probe, to get close, very close by human standards. It is currently travelling through the outermost atmosphere of the sun, called the corona. Even there, far from the visible surface, it must be protected by an advanced carbon heat shield just to survive for a short while. The sun's corona, though thinner than the air you breathe, is heated to over 1 million degrees Celsius. Why? No one is quite sure. The outer layers of the sun are somehow hotter than the layers beneath them. A mystery that continues to puzzle scientists. A mystery that reminds us the sun still holds secrets we cannot touch. And the closer you get, the more impossible it becomes. No amount of technology, no future invention could ever allow us to stand on the sun. Because the sun has no surface. It's not a solid ball. It is made entirely of plasma, a soup of charged particles so hot that it defies the structures we're familiar with. If you drop something into it, it wouldn't fall. It would be pulled, melted, vaporized and scattered in moments. To approach the sun would be to dissolve, to be erased. And that is what makes it so strange and wonderful, that the very thing that makes our lives possible, the very source of our light, our food, our breath, is also something we can never truly approach. It gives freely, it shines constantly, and yet it cannot be touched. There's something sacred in that, something humbling, because we live in the gentle shadow of a force we can neither tame nor reach. And even from this close distance, the sun holds us in place. It anchors our orbit. It commands the planets, the comets, the asteroids. Everything in the solar system moves because of the sun, pulled not just by its light, but by its gravity. Even now, as you sit or lie down, quiet and still, you are moving. The Earth is circling the sun at nearly 30 kilometers per second, faster than any jet, faster than any missile. And the sun itself is moving too, dragging us all through the galaxy on a larger, deeper journey we cannot feel. We do not sense it, but we are always in motion, carried by light, held by gravity, tied to a star we can never hold. So when we say the nearest star isn't that close, we are speaking a quiet truth, not just in kilometers, not just in temperature, but in essence. The sun is near enough to give us life, but distant enough to remain unknowable. It reminds us that some things are meant to be admired, not possessed, that some gifts are too large to hold, that the most powerful forces in our lives are often the ones we cannot touch. So let the sun be what it is, a star that rises for you each day, that burns for you, that lights your path and feeds your world and gives you warmth from far, far away. And know this, you don't need to reach it, because it already reaches you with every sunrise, with every golden ray, with every breath you take. In our quest to touch the stars, to build, to reach, to imagine, one natural question arises. If we can't go ourselves, could we send something in our place? A machine, perhaps? A spacecraft? A clever piece of technology made from the hardest metals, wrapped in the strongest shielding, guided by the most precise computers. A silent messenger, sent across the dark to do what we cannot, to reach the stars for us. But even our machines, resilient and enduring though they are, face the same quiet truth we do. Even robots would melt, because the stars are not places where matter can survive. They are not distant platforms waiting to be explored. They are not destinations in the way that a mountain or a moon is. A star is a place of such extreme energy and heat that anything, even the toughest, most advanced object we could possibly imagine, would be utterly destroyed before it ever got close. Let's return for a moment to our own sun. We've already sent robotic probes to study it. The Parker Solar Probe is the closest any human-made object has ever come to a star. It's an extraordinary machine, a triumph of engineering, built to fly through the sun's corona, the blazing outer atmosphere of our nearest star. At its closest approach, it travels within just 6 million kilometers of the sun's surface. That might sound like a large number, but in the scale of space, it's astonishingly close. And at that distance, the probe is exposed to temperatures exceeding 1,300 degrees Celsius. To survive, it carries a thermal shield, a specially engineered plate of carbon composite foam covered in white ceramic paint, designed to reflect and endure the intense solar radiation. And even with all this, the spacecraft is not touching the Sun. It's not even close to doing so. It's still flying millions of kilometers away, just brushing the edges of the Sun's presence. If it were to go any deeper, into the lower atmosphere, closer to the actual visible surface, it wouldn't matter how strong the shield was. The heat would overwhelm it. The radiation would destroy its instruments. The magnetic fields would tear it apart. Because the Sun is not just hot in temperature, it's hot in every possible sense. It radiates across the entire electromagnetic spectrum. From gamma rays to X-rays to ultraviolet light, it floods space with energy. And no known material can endure that forever. Now imagine trying to send a robot, not just to our Sun, but to a larger, more volatile star. A red giant, or a blue supergiant, or even a young rapidly burning star just coming into its prime. These stars are larger, brighter, and far more dangerous. Their energy output is hundreds or even thousands of times greater than our Sun's. Their solar winds, streams of charged particles, are powerful enough to strip the atmosphere from planets. Their flares can stretch millions of kilometers into space. Their magnetic storms are violent and unpredictable. No robot, no spacecraft, no probe could survive such an environment. Even approaching the outer edge would mean facing forces so intense they would reduce any machine to vapor in moments. Circuits would fry, metals would melt, data would be lost, the robot would be undone, not in a fiery crash, but in quiet disintegration. Not with a bang, but with a whisper. And even if we could somehow build something that didn't melt, that survived the heat and radiation, there would still be no surface to land on. Stars are not solid. They are made of plasma, a superheated state of matter where atoms are stripped of their electrons. Plasma flows like a fluid, but behaves in strange and complex ways, governed by magnetic fields and turbulence. There is nothing to stand on, nothing to attach to, nothing to grab hold of. A robot, even if it arrived intact, would fall into the star's layers, sinking deeper and deeper, experiencing ever greater pressure and heat, until it was crushed, ionized and erased. Not only would the robot fail to complete its mission, it would never send a signal back. Because signals, too, are vulnerable. Radio waves, like the light we see, can be absorbed or scattered by the intense activity near a star. Communication would break down. The probe's last words, if any, would be lost in the roar of solar energy. And so we are left with a humbling realization. Even our most brilliant machines, created with care and intelligence, cannot conquer the stars. They too are bound by the same laws we are. Bound by temperature, bound by energy, bound by the fundamental limits of matter and motion. It's easy to think of machines as being stronger than we are. In many ways they are. They can survive the vacuum of space, endure the cold of interstellar darkness, and travel farther than we ever could. But they are not invincible. They are made of matter, just like us. And matter, no matter how strong, cannot exist where a star is alive. And perhaps that's a gift, because it reminds us that stars are not just physical objects. They are something more. They are beyond reach, not just in distance, but in essence. They are not ours to possess, not even to approach. They exist in a realm beyond touch, where only light is free to travel. So we observe, we listen, we measure from afar, we learn patiently, quietly, respectfully, and we send our robots not to conquer, but to witness, not to land, but to feel the edge of the fire. They do not melt in vain. Their journey is a message that the universe is vast and powerful and not made to be held in our hands. And yet, through their sacrifice, we come to understand just a little more, a little deeper, a little truer. Not by touching the star, but by getting close enough to know we never can. And that is its own kind of wisdom. To know the boundaries, to honour the flame, to stand at the edge of the impossible and feel wonder, not disappointment. Because even if we cannot reach them, the stars still shine for us. Their light still finds us. Their story still moves through our lives like a slow, glowing thread. And tonight, as you drift into sleep, remember, there is beauty in distance. There is power in what remains beyond our grasp. Some things are not meant to be touched, only treasured, only dreamed of, only admired from the comfort of the dark. When we think about the stars, their heat, their distance, their mystery, we often imagine them as unreachable flames forever beyond our touch. But somewhere in the quiet corners of our imagination, a different question arises. A playful one, a dream whispered across the silence of the universe. What if we could bottle a star? Not fly to one, not land on one, but take a piece of it, hold it, harness its light, its energy, its power. Like capturing the sun in a jar. A tiny star flickering in our hands, warm, contained, glowing. It's a fantasy so old, so human, that we've tried to bring it to life right here on Earth. In a way, this dream lives inside every light bulb, every glowing screen, every warm beam of sunlight we invite into our homes. But the real heart of this idea, the true core of bottling a star, goes deeper. It's about fusion. At the centre of every star, hydrogen atoms are pressed together with such intense pressure and heat that they fuse into helium. In doing so, they release vast amounts of energy. It's this process, nuclear fusion, that powers every star in the universe. It's steady, efficient, clean, and incredibly powerful. If we could recreate that process here, if we could build a tiny sun, a star in a box, we could have a nearly limitless source of energy. No pollution, no carbon, no toxic waste, just light, just warmth, just the quiet heartbeat of a star captured and tamed. And we've been trying. For decades, scientists and engineers around the world have been chasing this dream. From laboratories in Europe and Japan to massive research projects like ITER in southern France, we are building machines the size of cathedrals to hold the heart of a star. Not with glass jars or glowing spheres, but with something far stranger, magnetic fields. Because to bottle a star, you must first create a space where no container can survive. The temperatures inside a fusion reactor can reach over 100 million degrees Celsius, hotter than the core of the sun itself. No physical material can touch that without being vaporized instantly. So instead, we use magnets, powerful, invisible forces, to suspend the hot plasma in mid-air, keeping it from touching the walls of the chamber. This delicate balance is what makes fusion so difficult. It's like holding fire with your hands without ever letting it touch your skin. Any instability, any wobble, and the reaction stops. The flame disappears. And yet we persist. We persist because the dream is worth it. Because to bottle a star would mean more than just energy. It would mean independence, clean power for cities and homes, desalinated water for dry lands, lights that never flicker. A future built not on burning, but on glowing, not on taking from the earth, but on emulating the sky. But it's not easy. The dream is still just out of reach. The technology is evolving. The systems are being tested. Success may be decades away, or longer. But every attempt, every experiment, every spark of plasma held for just a few seconds longer than before brings us closer. And maybe that's what makes it so poetic. That we, small creatures on a pale blue planet, are trying to do something the universe has been doing effortlessly for billions of years. That we are learning, slowly, carefully, how to copy the stars. Not because we want to steal their fire, but because we admire it so deeply. Because we've seen their light, and we've wondered what it would be like to share in that brilliance. To carry it with us. To make it our own. But here's the secret. We already have. Not in reactors or labs, not in wires or machines, but in our bones. Because the same process that happens in stars, the fusion of atoms, the creation of light, is what forged the elements that make up your body. The carbon in your muscles, the calcium in your teeth, the iron in your blood. These elements were made in the hearts of stars long ago. They exploded into space, drifted through the galaxy, became part of the dust that formed our sun, our earth, our bodies. So you see, in a very real way, you already are a bottled star. You are a container for ancient fire. You are the glowing memory of a sun that lived and died before Earth was born. You don't need to build a reactor or hold plasma in a magnetic field, because within you, within every heartbeat, every breath, is the echo of that same light, that same fire. You carry it with you, always. And yet, we still dream. We still try. Because there's something beautiful about reaching for what we already are. About striving to understand what lives within us. About honouring the universe by recreating its magic piece by piece, spark by spark. So the next time you hear of scientists chasing fusion, remember, they are not just building machines. They are chasing starlight. They are crafting instruments to hold wonder. They are making lanterns out of time. And perhaps one day, when the world is quieter, when the skies are cleaner, when the lights never flicker, and the oceans are full of fresh water, we will sit beneath the stars, warmed not by burning fuel, but by bottled sunlight. And we will remember that once, long ago, we dreamed of holding a star, and that dream came true, not with fire, but with light. There is a kind of silence in space that we cannot replicate on Earth. It's not the silence of a quiet room or a peaceful forest. It's not simply the absence of noise. It is a deeper kind of silence. The silence of nothing. The silence between the stars. We often speak of space as empty, but that word doesn't quite capture the stillness. Space is not merely blank, it is vast beyond imagination. It is not quiet like a whisper. It is quiet like eternity. Between the stars lies a cold, immense distance. A black ocean with no waves, no winds, no shores. It stretches in every direction, endless, open and still. And in this great cosmic sea, the stars float like lanterns, flickering across unimaginable gulfs of darkness. This silence, this cold space between us and the stars, is the reason we will never touch them. Not because we lack the courage, not because we lack the imagination, but because the distance is more than just physical. It is fundamental. It is part of the fabric of the universe. You see, between every star and every other star is an immense, quiet emptiness. And that emptiness is growing. The universe is expanding, slowly, silently, like the exhale of some invisible breath. Galaxies are drifting apart, not because they are moving through space, but because space itself is stretching. The very foundation of reality is unfolding, like a great, invisible web being pulled gently in every direction. And this means that the cold silence between us and the stars isn't just wide, it's widening. Each second, each moment, the stars are receding. Their light still reaches us, for now, but the space between grows larger with every heartbeat. Someday, far in the future, the stars we see tonight will fade, not because they've died, but because their light will no longer be able to cross the void. It will be stretched too thin, scattered too far. The night sky will go dark, slowly, until only the memory of starlight remains. But here, in this moment, we still see them. We still feel their presence. And yet, between us and them, lies a barrier greater than fire or gravity. A barrier of absence, of distance, of silence. This cold silence is not hostile. It is not cruel. It does not reject us. It simply is. It is the space between things, the space that defines things. Because without it, there would be no stars, only one blinding wall of light, no shape, no form, no contrast. The silence is what lets the stars shine. It is the canvas for their brilliance. And perhaps in that way, it is not a barrier at all. Perhaps it is a gift, because the cold space between us and the stars gives us perspective. It gives us wonder. It gives us the chance to look up and long for something greater. It is the emptiness that makes beauty visible, the darkness that gives meaning to light. Still, it can feel lonely to stare into the sky and know that the nearest star is 4 light years away. That every twinkle you see is a sun like ours, surrounded by its own planets, its own silence. That we are alone, not absolutely, but physically. Alone in the sense that no voice has ever crossed that distance. No foot has ever touched another world outside our system. No ship has ever returned from the stars. It is easy to feel small in the face of that distance, but maybe that's the wrong way to think about it. Maybe what matters is not how small we are in the cold silence, but how bright we are. We are little, yes, but we are not dark. We are made of light, of energy, of warmth. We are atoms that once floated freely through the galaxy, drawn together by chance and time into something that breathes, Sphinx wonders. And we do wonder. We sit quietly on a spinning planet, hurtling through space, and we dare to imagine what lies beyond. We build telescopes to see farther. We write equations to understand gravity. We launch probes into the dark, knowing they may never return. We whisper our stories into the void. And though the void does not answer, it listens. The silence of space is not the silence of neglect. It is not an empty room where no one hears you speak. It is a silence that receives, that holds, that echoes gently the quiet songs of planets and stars and distant galaxies, and through that silence, the stars shine. And through that silence, their light reaches us. Tiny photons, born in the heart of a sun, travel for centuries through absolute nothing, only to end their journey when they meet your eye. They land on your skin. They pass through the lens of your telescope. They flicker in your dreams. That is the miracle of the cold space between us. It allows for connection, not by touch, but by light. Not by sound, but by wonder. And in that stillness, something beautiful happens. You begin to listen, not with your ears, but with your being, with the part of you that feels the pull of mystery, that lies awake at night and gazes upward, that aches not for answers, but for the comfort of knowing you are part of something so vast, so silent, so luminous, that it cannot be spoken. It can only be known in the heart. So tonight, let the cold silence wrap around you like a blanket. Let it hush your worries. Let it soften the noise inside your mind. You're not lost in that silence. You're held by it. You're not forgotten. You're part of it all. You're the small light in the dark. You are the warmth in the cold. You are the question, and you are the answer. And the stars are still shining, even across all that space, even through all that silence. They are shining just for you. If you were to strip away everything you know, your name, your thoughts, your story, what would be left? Beneath all the layers of who you believe you are, beneath your skin and bones and breath, what remains? Stardust. It sounds like a metaphor, a romantic idea, but it isn't. It's a scientific truth, whispered through the language of atoms and galaxies. Every element that makes up your body, your carbon, your calcium, your iron, was once formed inside a star. Not just any star, but one that lived and burned and eventually died in a great explosion called a supernova. In that final moment, it scattered its contents across the galaxy. And over time, those scattered pieces became the building blocks of new things. New stars, new planets, new life. And you are made of ancient light, forged in fire, shaped by gravity and time. When you run your fingers through your hair, you are touching atoms born billions of years ago. When you breathe in, you are taking in oxygen that once floated through clouds of interstellar gas. When you feel your heart beating, that rhythm is powered by iron created in the final breath of a dying star. So when we talk about the stars being far away, when we mourn the fact that we can never touch them, we forget something very important. They've already touched us. They are inside us. Not figuratively, literally. The stars do not live only above. They live within, in our cells, in our thoughts, in the quiet electric storm of our minds. When you fall in love, when you cry, when you laugh under a full moon, those feelings are carried by molecules that were once part of the universe's earliest generations of stars. You're not separate from the cosmos. You're the cosmos experiencing itself for a little while in human form. And maybe that's the closest we ever come to touching a star. Not with our hands, but by remembering what we are. We are the continuation of the star's story. We are the echo of their light. We are their dreams, walking softly on the surface of a quiet planet. And in that way, the longing we feel when we look at the stars is not a longing for something other, but a longing for something we've always known, a kind of homesickness, a quiet pull back to the place we came from, the fire we remember in our bones, the silence we remember in our sleep. So when you lie back and gaze at the night sky, you're not just observing, you're remembering, you're reconnecting with something ancient, something buried deep within your being, something that doesn't need words, it just knows. And sometimes, when you forget, the stars are there to remind you that you shine too, in your own way, in your own time, that your life, your light, your presence is just as miraculous as theirs. And so, the question returns, if we can never hold a star, how can we truly touch one? The answer may be simpler than we think. We touch stars through wonder, through stillness, through awe. We touch them by carrying their story forward, through love, through kindness, through every small act of beauty that ripples outward. And sometimes the smartest way to touch a star is not to reach for it at all, but to be still enough that it reaches you. Because that's what starlight does. It travels, it searches, it finds its way through the dark, through space, through time, across unimaginable distances, just to brush softly against your cheek. Light is patient. It does not rush. It does not worry. It simply shines. It doesn't ask to be noticed. But when it is, something sacred happens. You feel it. In your chest, in your breath, in the way your thoughts slow down, and your heartbeat quiets, and you become part of something larger than yourself. That is how you touch a star. Not with rockets, not with machines, but with presence, with silence, with reverence. And finally we come to the end of this journey, a journey that was never really about distance, or temperature, or velocity. It was always about connection, about wonder, about letting yourself drift beyond the boundaries of what is possible, and into the realm of what is meaningful. So now, as the stars begin to fade from view, and the sky shifts from deep indigo to the pale promise of dawn, it's time to say goodnight. Or perhaps, good morning. Wherever you are in the world, whether wrapped in blankets or travelling through thought, whether lying in a field or curled up in bed, I hope you feel it. That soft hum beneath everything, that quiet truth that does not speak in words but in light. You are part of this universe. You belong. Not because you've touched a star, but because you are one. A small, warm light, flickering gently in the dark. Brighter than you know. So sleep now, or rise slowly. Let the stars keep watch over you. Even as the sky brightens, they are still there, always there, and no matter how far they may be, they are never truly out of reach. Not when you carry their fire in your heart. Good night, traveller, from the farthest edge of the universe to the quiet space behind your eyelids. Sleep in starlight, and remember, the stars are not above you, they are within you always.